Hi everyone. In this video, I'd like to show a couple of examples of tracing code so that we can gain a better intuition of what's going on. When we test our programs, we can have various issues with them. Syntax errors are things that cause the program not to compile. Runtime errors cause the software to crash. But most importantly for us for code tracing is logic errors. The software maybe runs fine, but it produces incorrect results. By learning how to trace, we can determine what is actually going on logically in our code and figure out if it's doing the thing that we expect. So let's start out with an example where I want to find the bug in a piece of code. I'll show you the code. Let's say I have double length is equal to 1.5 and double width, which is 2.0, and then double height, which is 2.4. Okay, and what I'm going to do is calculate or try to calculate double volume. That's going to be width times length, and then I've done volume plus equals length times height, and then volume times equals 2. All right, so what we're going to do is we're going to step back from the code that we've typed and think about what the volume of a rectangular prism should actually look like. Okay, so I know that if I have a length of 1.5, I want to multiply it by 2.0 and then get 2.4. And so if I see that and I multiply that out, I know that the volume should be 7.2. Okay, now this is not what's happening in this code. I do have width times length. Okay, I think that makes sense because I would want to have length times width times height. And I do have length times height, so that makes sense. But something else is going wrong. If I calculate out what width times length is in this context, which is 2.0 times 1.5, I will get 3.0. Let's use a darker color. And then if I do length, 1.5 times height, I'll get 2.4, which is 3.6. And I know that I want to add that to volume because the volume plus equals. So that's going to be 6.6. And then I'm going to multiply that by 2. And 6.6 times 2 is 13.2. So I expected 7.2, but I got 13.2. So we can see by working out by hand what we expect to get, maybe with the help of a calculator, that this is not what the value that we want. So this is the idea of code tracing where at the bottom here, I've written down the things that actually happen based on the code I've written. Another place it's important to trace code is with conditionals. So here I have a sequence of if and then else if. So if x is equal to 1 already, I'm going to update it and set it equal to 4. Else if x is equal to 2, I'm going to update and set it equal to 4. Else if x is already equal to 4, then I'll set it equal to 5. Else I'll set x is equal to 20. So with code tracing for conditionals, what you want to do is figure out what's going to happen on each of the branches. For example, we can determine what will happen if x is set to 2. So in that case, we would say, okay, well, if x is set to 2, I will get the output of 4. But if x is set to 4, then I know I'm going to get an output of 5. And then another thing to do is to see what will happen when x is set to anything besides 1, 2, or 4. For example, 5. Figure out what those prints are going to be. So I know the first time if x is set to 4, it should print 4. If it's set to 4, it should print 5. And if it's set to 5, it should print 20. And now when I run my code, I can actually see whether that happened or not. So tracing here has helped me find some potential bugs in my code. Another example is with nested conditionals, where it really becomes important that you know what the scope of the if statements are. So this basically, for tracing this involves figuring out where the ends of the curly braces are, if they have it. So inside the first if statement, I have another if and an else. So these two go together. And then lower down inside the bigger else, I have an if statement here and an else here. So those two go together. And then finally on kind of the top level, I have if x is equal to y. So that goes with this else. And now highlighting helps a lot because it's way easier to see what the structure is. So here I have an example of x is equal to 5, y is equal to 4, and z is equal to 3. So let's give it a shot. If x is equal to 5 and y is equal to 4, and I'm actually writing this out, does 5 equal 4? No. So I know that I need to go inside my else. Inside my else, I'm going to see and check if when x is equal to 5 and z is equal to 3, well, is 5 equal to 3? No. And so I know that I'm not inside this if statement either, so I'm expecting this to print out Tempa. Let's do another example where I have x is equal to 5 and y is equal to 5. So in this case, if I have x is equal to 5 and y is equal to 5, I can check, is 5 equal to 5? And the answer is yes. So I know I'm inside this if statement. So the next thing to check is if x is equal to z. So x is equal to 5, z is equal to 3. Is 5 equal to 3? No. So this is false, and I'm expecting this thing to print out capicola. Okay, so this gives you a way to think about nested conditionals where I'm just writing out different cases for, in this case, particular numbers to see what's going on. Code tracing also involves making sure you can do the Boolean logic associated with something. So let's say that I give you the starter of some variables. Control 1 is equal to true, control 2 is true, control 3 is false, control 4 is false. And then I have some Boolean conditionals, cond1 and cond2, which are mathematical expressions that evaluate to either true or false. So let's say beyond that, I say, what is control 1 and control 2? Okay, if you write this out, I see that control 1 is true and control 2 is true. So I know that overall this will be true. All right, so this, for tracing this, you needed to be able to do the Boolean logic. Another example is control 1 and not control 2. Okay, control 1 I know is true, and control 2 is true, and therefore not true is false. And this is an and, so overall this will give me false. Let's say I have control 1, which is true, ORed with not control 2, which is not true, therefore it is false. Since this is an OR, I know that at least one is true, that the overall thing will be true. Right? So these give some examples of different things that you have to like work out the logic, maybe step by step, to be able to trace conditionals. Let's do an example that includes the cond1 and cond2. So before we start evaluating the expression, we have to make sure that we know what cond1 and cond2 evaluate to. So in this case, I have 20 and 10 times 2, which is 20. 20 is in fact equal to 20, so that's going to be true. And then here I have 7 divided by 2.0, which is 3.5. Is that greater than math.pi? Math.pi is about 3.14, so that's also going to be true. Good. So now that I've evaluated those, I can go into my statement and I'm going to say, okay, I want cond1 or, hey, I don't care anymore. And then not cond2. So not cond2, cond2 is true, therefore this is false. All right, and so since I have true, something that evaluates to true, and then false, the overall will be false. And you'll notice here I didn't care what control 2 was because the first thing already evaluated to true in an or statement. Good. Now let's get to the really important part with code tracing, which is to figure out what's going on with methods. For methods, although you should understand the entire header and know what each of these colors mean, what's really going to be important for tracing is going to be the return. So the return type and the input parameters. And one thing that's really important here is order matters. Okay, so I see that the return type is a double, and I see that I'm returning total, which in fact is a double, so I know what my return is. And so now that I know what input and output are, I'm really happy. Right? So whenever I do my pseudocode, I always write the input, which is going to be subtotal and tip, and I'm going to write the output, which is going to be the total, right? That is like step one with understanding what a method is doing. Okay? So now let's put this well, not this method, but a method into context with the rest of the code. So here I have a code tracing example that has a main, and it has a call, as you can see here, to a particular method, which is below it. When you are doing this tracing that has a main method and then has some other method in it, there's going to be basically 3 steps. Step 1 is going to be explaining initial values or explaining what's like happening initially in main. 2 is going to be describe any changes that are made by method calls. And 3 will be to write expected output. Okay, so let's keep that in mind as we continue. Now, when I'm doing tracing, I actually write out by hand what's going on. So the first thing I want to do is describe what's happening initially in main. So I see that x is equal to 3, y is equal to 5, z is equal to 7, and then z is equal to mystery function x, y. And I see now as well that since z is equal to 7, but then z is set equal to the mystery function, the value of z does not, that's set above, does not matter. Great. So now I have basically the initial values of x, y, and z. So the next thing to do is describe the changes made by the call to the mystery function method. So here's how I'm going to do it. Mystery function of x, y, I'm actually going to write mystery function. And I'm going to put in these values of x and y, because remember, this is all in the main. And it's going to be a replacement with 3 and 5. Good. So now let's move on to the next step of seeing what's happening inside the method. So now that I know I'm calling mystery function 3.5, when I look at the mystery function code, A is 3 and B is 5. That's how the things are set from here. So now I can update each of these values. So I'll write it like this. A is equal to 3 and B is equal to 5. And then let's keep going from there. So C is equal to A times 2, which is 3 times 2, which is 6. Okay, so now I have this new thing called C. And then B is equal to its original value, which is 5, plus C, which is 6, so it's going to be 11. So this B is now 11. And then finally I have A, and A is A plus B, which is going to be the original value of A. It didn't get changed yet. Up here, plus B. Now B is 11, so that should give me 14. Okay, so now we need to basically get ourselves out of this method and go back into the main. So I can see that I have a return, and that's going to be whatever that value of Z is at the end. So at the end, I had set A to be 14. So that's what's going to be returned. So now back in the main method, I still have X is equal to 3, Y is equal to 5, and Z, which is equal to mystery function of 3, 5, which I now know based on the return value is going to be equal to 14. So then looking at my print, which is here, I know that it's going to print out something that looks like X. X is 3, Y is 5, and Z should be 14. Good. So that is where I'm writing the expected output. Well, let's see if it's actually working out to what I expect. So I have that code typed up, and I'm going to just compile this code. And now I'm going to run it. And I see that X is 3, Y is 5, and Z is 14. So that prints out as I expected it to. Great. So just checking my handwritten answer against the code that I typed up, X3, Y5, and Z14, it matches, and so I have properly gone into the method and come out and selected values as they should be. And so I hope with this example, it helps you understand how to trace code when you go into methods. This is a really important skill, so do practice it. But that's all I have for you right now, so thanks for watching.